Good evening, everyone. Today I'm going to show you how to enter data into R without using a CSV file as a middle step between doing that. Sometimes you just have the data and you don't want to spend all this time entering it into one program to get it to another one. There's ways to do that. So the example we have today is we have a professor who wants to know if there's a relationship between the amount of hours their students spend studying and the grade that they get. So we have our data here, 10 participants, and we have one variable, hours, and then one variable, which is grade. So we're going to enter these in, and we're going to do some analysis on it. So to start, we're going to take the hours variable. I'll set it as X, and that is going to be entered with the function C, which means to combine. So these numbers are going to be a string of data that are going to be combined into the variable known as X. So we're going to do 10, 5, 11, 8, 7, 15, 9, 4, and 7, and 9. And then we just check X. It's all in there. We're going to set the DV, the grade, the output variable to Y. And we're going to do the same thing. C for combine, and then parentheses to get the things that need to be combined in there. I got 90, 86, 85, 93, 90, 92, 99, 82, 91, and 95. And there's Y. We'll just check and make sure that's in there. And at this point, you are probably and reasonably wondering, how does R know that these are paired up the way that they are paired up here? And the answer is that R takes data in order and works with it in order. So all variables, I could enter 100 more variables. If they're all in the same sequence, they're going to be related in that way. So let me show you how that will work here. So we're going to make what's called a data frame, and there's a function called data.frame, data.frame, and that's how we get these two data to be related to each other in a meaningful way, kind of like they are here. And you'll probably notice I didn't enter participant number, and you'll see how that will be added for me. It's implicit, the order. So let's make a data frame. I'm going to call it data, and that is going to be a data.frame, and we're just going to use X and Y. Again, quick names for your variables, like 1 to 2 to 3 letters, ideal. You don't want to have the full name of your variable. You're going to spend your whole time typing, and it gets obnoxious quickly. So there's our data entered, data, and you'll see that we have the participant number right here on the side, and everything should line up correctly as it does. And the idea is that when you have these things in order and you make a data frame out of them, it combines it, and then you can make your statistical analysis happen on that. And that's what we're going to do. So we're going to work the example that I'm giving here, and it's to figure out if there's a relationship between hours and grade. And when I hear relationship, I think of correlations, like correlation coefficients and scatterplots. And those kind of descriptive statistics can summarize the information and give us a general feel for how those two variables are related. In case you don't know what a correlation is, I'm going to take out my handy Rosnow and Rosenthal Beginning Behavior Research book and read what a correlation coefficient is. Maybe it will enlighten a little bit. A correlation coefficient, an index of the degree of association between two variables, typically Pearson R or related product moment correlation. That's okay. That's not really quite as helpful, maybe. So in English, correlation coefficient is just a number that goes from 0 to 1 that describes how two variables co-vary with each other. So for each change in X, what is a change in Y? That's what that number is going to explain. So to get a correlation coefficient, there is a function preloaded into R called core for correlation. And then you want to type data with your $sign to select your variable X. And then again, data with the $sign select for Y. and it will spit out a number. And that number is the correlation coefficient. As I said, it's from 0 to 1. Like a 1 is a perfect one-to-one correlation. For each one change in X, you get a one change in Y. That's like it doesn't happen in research. I've never seen it happen. I don't think it will, especially with large populations and samples. Anyway, so we got our correlation coefficient, and that is a numerical way of describing data. But if you're going to be presenting data, you're probably going to be asked to present it with numerical, but also with graphical data. And we can get a graphical representation of a correlation with the scatterplot. And there is another preloaded function in R, and it's just plot for scatterplot. And you're going to select your variables the same way. You're going to type the name of your data set right here. And then the $ means it selects each variable. I'm just going to say that again. Repetition is the key to success. I don't know what you're doing there. And now data $X, data $Y. And then boom, here is our correlational data in a scatter plot. So for each change in hours, we had how much of a change in grades. And there is a weak overall trend that is about a 0.4. We'll just round it up. And that could be like here. There are ways to add trend lines. There are ways to change the axes so it just isn't X and Y. And I'll get into those in future videos. For now, the idea was to show you how to get data in R, to make a data frame, and to do some very basic descriptive work on it. So thank you for watching. As always, the codes that I used are you can copy and paste them out of the description below. And if you have any questions, comments, concerns, corrections, which I'm sure there will be a lot of them, just leave a message. Yeah, call my phone and leave a message. You can leave a comment or you can send me a message and I will answer as fast as possible. Thank you for watching. Have a nice night, guys.